Okay, full screen. So, hello everyone, good afternoon and good morning, possibly. So, today I'm gonna bring this presentation about mRNA-tLNP for immunocAR-T challenge and solution. So, this is a line for today's talk. So, we split this into two parts. The first one, we're gonna give a very brief overview of the advances and challenges in vivo CAR-T therapy, and I will focus on our ProBio, the CDMO platform. Okay, so I think Dr. Xuan has already showed this slide for you guys, and I don't want to waste time here. So just let you know, now your CAR-T is rapidly increasing, and people paying more and more attention to this, just because mRNA-tLNP has a lot of advantages over the conventional ones. And in our handbook opinion, I think we got a lot of challenges still so far in this field. The first thing is we need to look for LNP formulation that originally has as a targeting affinity, and the second is we have to screen out the best antibodies with affinity, and then hopefully your AD team or your QC team has developed very mature analysis toolbox for the mRNA-tLNP production. And of course, we have to optimize our conjugation process. Okay, so here I gonna just give a very brief advertisement of our ProBio CDMO platform. So this is all-in-one platform, which means you just need to bring your idea here and we can do all the rest of the work for you. So from the plasmid construction and from the mRNA sequence design optimization and LNP formulation screening and the antibody design optimization. And we're gonna push this forward to the CMC production and the GMP production and to fully support your IND applications. Okay, so I'm gonna jump into our pathway of how do we do the mRNA-tLNP here in the ProBio. The first pathway I want to introduce you is surface conjugation. So we call this. So the first is, we try to we do the reduction of the antibody. So when antibody is reduced, so the first part is down, and then we do the mRNA-LNP encapsulation. So the difference of here, the LNP encapsulation is we try to introduce the fifth component of the lipid. So which means, for example, it's a maleimide pack. So this maleimide is an activated site on the surface of the mRNA-LNP. So this maleimide can conjugate it to the reduced antibody through the chemical reaction. So this is very simple, very robust. And after that, you just need to do the purification to purify the free antibody and other impurity, and you get your final product, mRNA-tLNP. So in our opinion, so we think this surface conjugation pathway is quite reliable. It's very controllable, and each step it gives you very certain and very clear impurity types, and so you know how to develop what you should detect and what you should purify. And according to our experience, so this process will give a very consistent result. But this pathway also got its drawback. So for example, the stability of the reduced antibody and the functionalized LNP here may not be that stable, so which means it won't last for days. We suggest you do the conjugation as soon as possible. And also, you need to do this continuous flow. So means you have to, I think you have to carry out for like 1 or 2 days continuous production. So it's gonna be tiring for your personnel. Okay, so we got the second pathway to do this tLNP production. We call it, still this is a surface conjugation, but based on different chemical reaction. So you can see the difference here. The first, so you link your antibody of interest to a DBCO chemical group, and then you still do the mRNA-LNP production and with your fifth lipid component. So for example, it can be AZ pack. So AZ can link to the DBCO group through the click chemistry, so which is also classic chemistry reaction and robust and simple. So after that, the link is very strong, so don't worry about that. TLNP, this is the structure will be intact. And after purification, you got your mRNA-tLNP. So this one is also, it gives you very, very straightforward and highly controllable process. And the impurity of each process is very clear, so easy to detect, easy to purify, and it also gives you very consistent result. However, so if you pay attention to this illustration here, so you will see we introduce a DBCO chemical group here. So this DBCO won't be removed after the conjugation, so it will go with your tLNP. So we still not very clear whether this will affect your bioactivity or not. So it depends on your antibody type. It depends on your tLNP type. So this is going to be case by case. But so far, according to our experience, so with the tLNP transfection or expression is also very good. So seems like you don't have to worry about that much. Okay. And the third pathway here, we call it post-insertion. So what does it mean? So when you do the antibody reduction, okay, you directly link the reduced antibody to the PAG lipid with maleimide or azide PAG. So this gives you a quite polydispersed muscle. So it's not monodispersed, it's quite polydispersed. The mass of the size may be like dozens nanometers. So itself, it looks like, it looks like surfactant, something like that. And for the mRNA-LNP encapsulation, so this is quite simple, just exactly as what you previously do with the classic mRNA-LNP. So nothing changed. And in the conjugation process here, there's no chemical reaction at all. It's just a physical reaction. So you try to let this muscle emerge with your mRNA-LNP. So this is a totally physical process. So they can do the self-reassembly. So they will form the final structure of the mRNA-tLNP. So what's the good thing of this step is, the mRNA-LNP process is the same as what you did before. And you can just take the mRNA-LNP in your fridge, which was made like 1 year ago, as long as the mRNA is still good. Okay, so you don't need to modify anything at all. Another thing is, if you are still not sure about which antibody you should use, you can do the antibody screening here. So you link this to the lipid PAG, and you can do the the test of the antibody activity on your cells or in mice, whatever. But this is much easier than the previous two strategies because you only can test your antibody activity after you link this to the final mRNA-LNP. But here you can just directly test your antibody activity after linking this to a simple lipid component. Okay, so it has all of the three strategies here. So it has its own advantages and disadvantages. So it depends on you, what kind of your pipeline, what kind of your LNP and antibody you want to use. So I hope I made myself clear here. And now I want to just jump to the case study here. So the first thing is we want to emphasize in ProBio, we have a very universal tLNP platform, which supports different LNP formulation. It means no matter the 0315 or SM102 or another, or your, so we can do commercial LNP formulation, and we can also accept your own LNP. Okay, so it doesn't matter because the chemistry here is very simple. So we don't worry about the LNP type. And for the RNA, so we can accept mRNA, we can accept circular RNA, we can do self-amplifying RNA or sgRNA. And we can also do co-encapsulation of different mRNA. For example, the linear RNA with the circular RNA at the same time. So no problem. And also we have tried all the types of the antibodies here, all the formats. So from the full-length IgG to the shortest VGG antibodies. So we tested all of them and all the results were successful. Okay. And the rest of this slide is, so you can see, so we can directly control how many antibodies linked on the surface of the LNP. So you see the size increased a little bit because you linked more antibodies onto the surface. But the good thing is you will not compromise the polydispersity index of your tLNP. So you can see that all of the PDI is still below 0.1, so which means your tLNP population is still so monodispersed. So it's very good. And the encapsulation efficiency, if you compare the LNP and the tLNP, you will find that the encapsulation efficiency remains the same. Okay, so means the structure of your tLNP remain intact, and also the cryo-TEM here prove what I said. Okay, and the second is, so we did a lot of chemistry work here. So thanks to my team, so we try to investigate on the process of the the reduction of the antibodies. You will see by controlling different reaction parameters, you see the reduction, the extent of the reduction is different, right? So apparently the number 8 line is the best because all the antibodies were reduced. And here, so we try to control the molar ratio of the Malay-made pack in the whole LNP formulation. I know the Malay-made pack takes a little share, but even this little share, you need to optimize. You need to play with it to find your the best value for you. Because even you just change a little ratio of the Malay-made pack, you will change the size, and you will change the zeta potential quite a lot. Okay, in this one, I want to continue to introduce our process optimization. So this is about our purification process. And I want to say first, the purification is very, very important. Why? Because when you down the LNP conjugation with your antibodies, there still will be some free antibodies in your suspension that it doesn't really matter how long time you put them, you leave there for their reaction, there still will be some free antibody. I can guarantee that. So you need to get rid of them very perfectly. So this is why. So if you don't get rid all of the free antibody, so for example, here's the one in the middle, you will see the cell expression level is just so-so. However, if you get rid of all of them, you will improve your cellular expression quite a lot. So why? Because the free antibodies, they gonna combine with the cellular receptor that will affect your indosome escape or the uptake of the tLNP. And in ProBio, now we can guarantee you we will get mRNA recovery rate over 60%. So this is how we define the recovery rate. So we take the mRNA input as a whole, so which means the mRNA you got from the IVT process, and we compare this to the mRNA encapsulated in your final tLNP. So this is how we get 60%. So this one is, so we want to show you two things that we can control the numbers of the antibody linking to the surface of the LNP. The first thing is we can tune the Malay-made pack in the ratio in your LNP. So if you increase the Malay pack ratio in your LNP, you can just increase the antibody conjugated on the surface. That's very easy. So I will give you an analogy. It's like you have like a parking site for the cars. You can enlarge your parking site. So definitely you can stop more cars in it. Or here is, so if you don't enlarge your parking site, but you can also increase the antibody input. For example, you can just try to squeeze more cars into the same parking slot. So you still can park more cars in there. Okay. So you can see that we can just tune the number density of the antibodies on the surface step by step. And But I want to emphasize here for the cellular expression, it not necessarily means that more antibodies will give you higher cellular expression. It's not guaranteed. Actually, the best cellular expression only comes with the, I would say, maybe the medium antibody density there. So we have several reasons for this explanation. So the first thing is very clearly, so if you got more antibodies on the LNP, you increase your LNP size too much. And we know if the LNP size is too much, cell doesn't like it, right? So it affects the right chart, the yellow bars. So it not necessarily means higher number density or more antibody linked to the surface of the tLNP will give you the best or the better cellular expression. Not necessarily. Actually, there is an optimal range there. So the reason is, so we think could be first, if you link the too many antibodies onto your LNP, the size will be too large for the cellular uptake or endosome escape. The second reason is more antibodies, they will affect your zeta potential of the LNP. So you know that will affect the cellular uptake too. The third thing is, so if the antibody density on the LNP surface is too high, so when one antibody try to link to the cellular receptor, so their neighbor antibodies may interfere with it. So this is just my guess, but I don't have direct proof for this. So I want to introduce you one term. So we call this LNP surface antibody modification positivity rate. This is quite a long term. I don't like this, but anyway, so what does this mean? This means how much in your LNP population were finally turned into the tLNP, which means at least linked to one antibody on the surface. Okay. And in ProBio so far, we can easily guarantee we will have this positivity rate over 95%. It's very easy. And it doesn't really matter about your antibody format or your antibody format or LNP formulation. So we can do that, no problem. And I want to also give you a very straightforward feeling about it. The number density of the antibody on one surface. So here we use ELISA and nanoflow to quantify how many antibodies on the one surface. You can see for this case, tLNP number 1, so the concentration with the antibody is like 52, and you calculate this, by the simple math. You see like 19 antibodies on one LNP. Okay, this is the case 1. And in another case, number 2, so when the concentration of the antibodies seems roughly on the same magnitude. However, the numbers of the antibody on one LNP varies quite a lot. Okay, so this is more than 200. So what's the difference? So the antibody type is different. So in case 1, the antibody, we use a full length IgG, and number 2, we use a smaller one, VHH. So when you talk about the number density of the LNP of the antibody, so be careful. So you need to specify your antibody type because a longer one and a shorter one, that is quite different. Okay. And below we got the data to show our tLNP works well. So on the left, we got a Jukate cell. And you can see if you don't link anything onto the surface of LNP, so you almost don't have the expression. And for the tLNP with a good antibody, so you improve your cellular reception quite a lot. However, if you link the LNP to a non-specific, which NS here stands for a non-specific antibody, so you decrease the cellular reception expression quite a lot. So which means it is the very antibody that gives you the targeting capability. And if you knock off all the cellular receptor on the triggered cells, you got all the group dropping down so dramatically, right? Because there is no antibody receptor conjugation. So cellular expression. And for PBMC, we even use very, very little input of the tLNP. You still got a very high transfection ratio. But for the non-T cell, sorry, we don't get the transfection ratio. So which means we have very, very targeting, a specific targeting capability of this. I think these two figures give very, very good evidence of our tLNP targeting capability. And the case number 4 is a preliminary studies of the stability. And like I just mentioned before, so the tLNP is quite stable over a long time. So I guess I don't need to just explain this charter one by one. But however, if we want to ship the materials to our customers, we still recommend we choose the deep freezing format. For example, minus 70 degrees or with the dry ice. Because we don't know if you got the liquid suspension during the shipment, the shaking, the sharing force, was they gonna affect the tLNP? We still don't know yet. And the freeze and thaw cycles, I think we can at least handle this for at least 3 times. I think that's quite enough for most of your in vitro and in vivo studies. Okay, this case number 5, actually, I don't really want to show this, but I think I should show it because this is the one just showing our team is working on the bispecific mRNA-tLNP. So this is designed by the ProBio Antibody Development Department. So they are trying to filing a patent about a new bispecific antibody. So the IP is owned by ProBio, by the way, and they haven't given me their best result. They only give me the so-so result because the filing with the patent haven't been done yet. So just give you a taste of that. So the purple one is exactly the bispecific antibody linking to the LNP. So antibody 1 and antibody 2, you will see is much better than the only single LNP, only single antibody, or the only one correct antibody, but linking to another, non-specific antibody. So the result here is just so-so, but the best results, they don't want us to show it here. So I just want to clarify that point. And the case number 6 here is we got a customer, they do co-encapsulation of 2 different circular RNA sequences. And after that, we coating this antibody onto the surface when we turn this into a tLNP. And I also want to, give a brief advertisement for our cRNA team because they can do the cRNA production very well with high purity and high throughput. Okay, so finally is we co-developed a lot new analytical methods for the tLNP because you have to characterize your samples. Otherwise, you won't know if your process is correct or not. And so here is a summary of our tLNP platform. So I want to emphasize that we got like more, I think we have more than 20 testing orders so far because we almost received at least 2 or 3 testing orders per week right now. And now we have 3 CMC orders and 1 IIT orders are undergoing. And for the CMC scale, we do at least 100 milligram per batch. Because if your throughput is lower than that, you just that volume or the higher the margin material cost would be high for us. And thank you. I would like to take questions here.
Yeah, thanks for Dr. Xu's presentation. Let's move to the Q&A part. Yeah, once again, we invite you to submit your question in the chat panel. And additionally, follow us on LinkedIn and Kakao channel for more online resources and updates. Now let's take a look at the first question. Could you also share the control strategy in CMC and regulatory for ratio between antibody and LNP?
Jessica, can you repeat the question again? Sorry.
Yeah, you can also find the question in the chat panel. Could you also share the control strategy in CMC and the regulatory for ratio between antibody and LNP?
Ratio of the LNP and the antibody. So I think I showed one slide here. It's my God. Can I share my screen here?
Yeah,
Share
sure.
as
Yeah.
can you see it here? Can you see it here, Jessica?
Yeah.
Okay.
Yeah, I can see.
So okay. This is basically the way we control the antibody to the LNP ratio. So there's two parameters you can play with. It's the malimic peg input. The more malimic peg you put there, so it means you have more potential activated surface conjugation sets for your antibody. And this one is if you don't want to change your malimic peg ratio, you can also play with your antibody input. Simply speaking, more antibodies, you gonna have more antibodies linked to the surface afterwards.
Thanks for your answer. And next question is, do you use NTA to find the number of total LNP and the tLNP?
Oh, to quantify the total numbers, I think NTA is a very powerful characterization tool. So I think you can use it. Here in the ProBio, we use Marvin DLS to do the number density characterization. And for the number density of the tLNP here, you have to use nanoflow plus LDS or NTA. I think they cannot tracking the they cannot classify, distinguish tLNP between LNP. You have to link, fluorescence antibody to that. So if you just want to calculate the number density of the tLNP, I think we suggest you use a nanoflow.
Thank you. Next question is, are PBMC for the tLNP test pre-treated for activation before use?
Okay, it's activated. Sorry, let me just double check. I just recently updated this one. It's very good question, by the way. And it's treated or it's activated or not. And let me double check. I think it's activated. Yeah. Yes, the PBMC cells are pre-activated. Yeah.
Okay, thanks. And next question is, when outsourcing tLNP to ProBio, what are the approximate production scale, cost, and time required?
Oh, I think sorry, where can I see the question from the chat box? How can I see? Oh, the new chat?
In the menu on the right, there is a chart.
Oh, I see. Okay. When outsourcing tLNP to ProBio, what are the approximate production scale, cost, and time required? Okay, for the testing order, so we can do this in 2 weeks normally. 2 or 3 weeks, I would say. So if you use this as an international order, so we can take the shipment time into account. So I would say 2 to 3 weeks for the testing orders. But for CMC orders, I think this case by case. And so far, so the undergoing CMC orders here is more than 9 months. here.
Okay, thank you. And for the cost and price, our commercial team can reply you through email. If you are interested, you can discuss with them. Okay, that's all the questions from my side.